In 4C, we are discussing savings plans and investments. In our last section in 4B, we worked with interest for one-time deposits. There were three formulas that we worked with: simple interest, compound interest, and continuous compound interest. These formulas did not consider what would happen if regular payments were made repeatedly towards a savings plan or an investment. This is the type of situation we will discuss in 4C. To show you the examples that we will be discussing, so the first one here, Kendall wanted to find out how much they would have from a one-time deposit of $500 into an account with an interest rate of 3.5%, which compounds monthly and will mature for 6 years. I see a one-time deposit here. I see an interest rate here. I see that it compounds monthly, and I do have a maturation date here. This is an example of a word problem that would use compound interest. We discussed this in section 4B. The second problem is different. If Lakin wants to find how much money she will have for retirement after making regular deposits repeatedly here of $50 each month for 20 years into an account with an interest rate of 3.5% that compounds monthly, then this is an example of a savings plan. So the differences here are that we're not making a one-time deposit. We still have an interest rate. We still have a terminal length here, but we are making repeated payments here. In these types of problems, we will have a different formula than we looked at in 4B. The formula is as demonstrated here. This is from your textbook. This will be what we call our savings plan formula. The savings plan formula, I encourage you to pause the video here and write this down. But to talk you through it, so here we have an A, which is our accumulated balance. So sometimes this may be referred to as your future balance, the future value of the account. This is equivalent to, this is all one expression, PMT would be your payment. This PMT is the regular amount that you are adding to the account each month or each week, determined by the prompt. We multiply this by this somewhat complicated term here, so we're going to break this down. We have a ratio here. In the top, you don't have to use brackets, you can use parentheses instead, but you'll notice that we have double parentheses here. I have 1 plus APR, which we're familiar with, that's still our annual percentage rate, so that will be a percentage. We'll often rewrite that as a decimal, divided by N. N is the number of payment periods per year here. This is calculated together, and then, because of these parentheses, that expression is raised to the N times Y. So this is a product right here, and sometimes it helps to simplify that before typing in the calculator to make sure you're using order of operations right. So N here is still the number of payment periods per year, and Y is the number of years. So if I had monthly payments, so a payment period 12 times a year, and then I had for 3 years, then this would be 36 because I would take my number of payment periods per year times the number of years. That entire expression, with the power included, we then subtract 1 from. You may want parentheses around this top instead of the brackets, and that's fine, but that would be our numerator, and then our denominator is a fraction here, and it's your APR divided by N. Remember that you can take the top of this and multiply by the reciprocal of the denominator. When we divide by fractions, it's the same as multiplying by the reciprocal. Okay, we're going to look at some examples with this problem, so please pause the video and don't move on until you feel comfortable with this problem, this equation. Now we'll work with this equation. We just want to practice using the calculator right now, so I'm going to ask that you find a calculator, the calculator you use for math, and I want you to use that equation with these variables. So PMT, we're going to plug in 20. For APR, because our APR here in this example is 2.3, we're going to type in for APR everywhere we see APR 0.023 as a decimal. N will be 12, and Y here will be 3. I'd like you to take a few moments, pause the video, plug those numbers in, and we just want to see if we can use this formula appropriately. So these are all of the numbers we have on the right side, and we're solving for A here, the future value of the account. So just to make sure that we understand, we are putting $20 in for monthly payments, so each month, and we're doing that for 3 years. So that's 36 total installments. Our annual percentage yield should be 2.3% or 0.023 when you type that in. Okay, once you've given yourself some time to try this in the calculator, then the goal is that you should be getting $744.68. Now, if you're not getting that number, I want you to take a few moments, check your order of operations, check that you have parentheses in the right place. I know that this can be frustrating sometimes, so just take some time, but the answer that you want to be able to get for these conditions here would be $744.68. I'm going to talk you through a bit. If we're making monthly installments that are $20, and we're doing that 36 times, so 36 times 20 here would be 720, and you'll notice this is a little bit greater than that because of the interest. So thinking about what we're doing here, the money that we're putting in each month for 36 times, that should kind of tell you if you're in an appropriate range. If your answer is very far off from 720, then you know that you might look for some mistakes that were possibly made when you entered this in the calculator. So take some time, work on that. Please reach out to tutors or me if you do have issues. And now we're going to work some additional examples. So in this example, Sue deposits $50 per month into an account which has a 1.6% interest rate, and she's going to do this over 10 years. So she's going to make 120 deposits since she's doing this monthly for 10 years. Take a moment and consider the numbers that this prompt has given us for each of these variables. So our parameters here for payment, this would be $50. Our APR, we might prefer typing in 0.016. In here is the number of times we make that deposit per year, so 12 for monthly, and then Y would be 10. Once you take some time to go through those numbers, then we're going to practice putting this into a calculator. Before we do, I want you to always take a minute and think about, estimate your answer. So just looking at this, we put $50 into this account every month for 10 years. 50 times 12 times 10 is already 60,000. I expect that this answer should be a little bit bigger than 6,000 since I'm making interest on this savings account. Especially if you think about it over 10 years, every single month you're making interest on the previous month's account balance. And so this should be greater than 6,000. If my answer is not greater than 6,000, then I might be surprised that I might look for mistakes, really. Okay, when you evaluate this on a calculator, please take some time to do this. You should get $6,501.97. This means that Sue deposited $6,000 over that entire 10 years. She made $501.97 just on interest. So just by keeping at that pattern of making monthly installments for that many years, she made $501, nearly $502. We'll look at another problem in an IRA for your retirement to encourage you to consider thinking about your retirement now. You are going to deposit $50 per month into that account, which has 3.8% interest, and you're going to do this for 40 years. So many of you are in your 20s right now, or near there, and so I want you to imagine right now, because if you think about this, then it'll really hit home and be more important to you possibly. So you're going to deposit $50 per month into an account for 40 years. Let's break this down. The PMT here would be $50. APR would be 3.8%, N would be 12, and Y would be 40. I want you to take a moment or two on a calculator. It's fine to take a couple minutes. Slowly, carefully type this in, and let's estimate that amount of money in the IRA. So once you've taken some time to do that, I do want you to notice before we actually get our calculator answer, it's always important to estimate $50 each month for 40 years is $24,000. This is the money that you are physically, it's coming from your check, your employer most likely, and it's going into this IRA, directly into this IRA. This is your money. But because you get interest on that IRA, we should have more than $24,000 in that account. So when we evaluate this using the formula, that is over 40 years. I want you to keep that in mind. Using this formula, we should have $56,000, $230.39. So $56,230.39. That may surprise you if you haven't worked with interest before. This is compounding. This is an exponential function because you have a power here. And so these numbers are going to grow. And if you have 40 years and you're making deposits every month, we've made about $32,230.39 in interest alone. So we actually put in $24,000 into this account, but the interest, just based on that 3.8% interest for 40 years, we made over the amount that we put in here purely in interest. So this problem is to really encourage you to start thinking about your retirement early.